Try to clear doubts. Okay, we'll wait for a few more minutes and then start. So, Rajiv, are you there?
Yes, sir. Yes, sir.
Okay, good.
Hello, I am audible.
Yes, sir.
Yeah. So same thing, like the last class. So we are discussing some assignment problems, and if you have any doubts, then you can write on the chat box also. Also, you can just suggest some, yeah, to know something like the previous class sir that took that class. You have any doubts in that also? So sir will discuss the next class in the upcoming class. So if you have any doubts, first of all, if you have any doubts, then ask. Then we'll start the assignment mm, solving. Otherwise, you can just write on the chat box also. So we'll wait 1 or 2 minutes if you have any doubts. Otherwise, we'll start the assignment problem because it will help uh, to you people in your end sem exam. Yeah. So if you have no doubts, so yes, just solve the assignment problem. So again, in the last class also, if people told us there is no query about that assignment problem, but we are trying to solve some of the questions, not all. So we can start. I can present the question.
Morning, guys. Hello. Could you hear me?
Yes, you're audible.
Yeah, thank you. So, I think I have completed till question number 4 in the previous class. So, and I know that you maximum one has that too that does that these questions. So, do you feel problem anywhere? Hello.
No, sir, it was fine.
Yeah, yeah. It's good. Can you say any similarity between question 5 and 6?
They are the same, only values
They
are
are the
given.
same. Yeah. The fifth one is a generalized one, and sixth one is some specific value has given. So here you have to do nothing. Just take an SZ. Applying operator means XX can be written as a lowering summation of lowering operator and raising operator, and for getting the probability related to the SX, initially you have to find the eigenvector and corresponding spinner, and then you can able to solve to that one. Nothing is you can say. Here also get the normalized constant, use the conjugation rule. Yeah, and find the SX, SY, SZ, just applying the operator and that. So all things are just means as if you able to understand the question number 5 and 6, anyone find and among 5 and 6, so you can able, in my view, you can able to do 7 and 8 all the things. So till today, what you have learned means I think sir has taught you about spin. Later on, he taught you about perturbation theory, and after that, he taught what variation principle. So, what is the difference between variation principle and perturbation theory? And how they are similar? Hello, hello.
Yes, sir, you're audible.
Yeah,
Yeah, take it as a discussion class.
yeah,
Don't take stress. Yeah, just
yeah.
answer.
We are as you. Don't worry. So, just say what similarity you find among them. Means variation principle and perturbation theory.
Sir, in perturbation, deviation is small and
Okay,
variation deviation is very large.
this is the difference. Yeah. What is the similarity?
Yeah. Both is approximation method
Okay. For what?
uh, to find the real system from the ideal.
Real system from ideal. Okay. Okay.
Yeah, how much we
So
deviated from ideal.
yeah. Can say. So the point is that we taken an ideal equations, make linear combinations, and use this approximation and try to reach the real system. Uh, how the variation principle, if someone has to justify variation principle or define the variation principle, how one can?
So what, sir?
If someone has to define variation principle, how one can?
So it is just a approximation where we consider a trial wave function, and by the help of that function we determine a energy, and then we minimize it, and then we compare that energy with the ideal, so on. I think so.
Okay. To minimize by minima condition, na? First derivation
Yeah,
should
yeah.
be, yeah, first derivation should be 0. And if resultant is not close to that, then what we follow to
Then
the
we will
perturbation.
consider it.
Yeah, if it not close to
That
that,
energy is considered.
yeah, we try to make a small correction, and that small correction is considered as a perturbation. Is it?
Yes, sir.
Yeah. So, have you learned about the virial principle in thermodynamics? Virial constant.
Yes, sir.
Yeah. So, can say this is a type of perturbation. The higher term, whatever they are. Can say this is a perturbation.
Yes, sir.
Yeah. So this is perturbation is nothing but we implement some correction or some extra term to reach the real value. So you have learned that there are many types of perturbation. Means first perturbation, second perturbation, third. What first degree of perturbation, second degree. What is the difference between them? And what do you think? The lambda term you have considered, na? During correction, during perturbation, you use one term lambda. Yes?
Yes, sir.
Yeah. What could be the value of lambda? If you have to apply some constant on lambda, so what lambda value will be possible? And why? Yeah. Should it will be can say it should be less than 1? Hello, hello.
Are you getting the
We
point?
consider that the perturbations are very small, then we can
Yeah, yeah.
say that.
So never your perturbation or correction should be more than the real value. So always it does the less than 1. That is that constant should have to be. Always the lambda value should be less than 1. If it will be more than 1, then if it is it will be equal to 1 or more than 1. So whatever things you have do by variation principle or by minimization, that will be going to what we can say contradicted. Is it okay? The correction, by correction, using correction, you are trying to reaching the real value. Yeah, and you made it some approximation, means you approximation is like variation principle, you find some ideal system which is close to the real system. Now you have to do modification. So modification never can be more than the real value. Yeah? Let's say real value is a 1 and you try to modify to that one. So never you can add something more than 1 inside to that one. Okay, so always lambda constant should be less than 1. That constant should be. And I think you know about that
Yes.
second perturbation does negative. Yeah, yeah. Second order of
Yes,
correction
sir.
is
Yes, sir. Yes,
yeah,
sir.
negative. Yeah. So and okay. So anything which you want to discuss? I'm not sure. I'm not rigid that I will be give you answer, but I will try. If you have any question, you can.
Sir, discussion like that is very fine.
Yeah, thank you. Yeah, say something.
Yeah, if you have any doubts regarding perturbation theorem and variance, you can discuss.
Yeah, either partition theorem, either variation or spin or whatever you have learned before mid semester. You can. I will try to discuss. I'm not sure that I will be give perfect answer, but I will try.
Hello.
Yes, yes.
Can you please solve the last question in the assignment? That will be helpful, I think.
Okay. Okay. Can you hear me? Hello. Hello.
Yes, you're audible.
Yeah. Good. So in question number 5, you try to find the probability for the Sx. Is it? For that, initially you have calculate the eigenvalue and eigenspinor related to Sx. Is it?
Yes.
So similarly, same things you have to find for the Sy. Is it okay? Sx and Sy both are written in the form of raising operator and lowering operator.
Yes.
So in that question, particular that question, you have tried to get the eigenvalue and eigenspinor of that. Later on, you get the probability. So same thing you have to do here for Sy.
Yeah, got it.
Okay, and same things I think, yeah, if you measure h2 square, what might you get and what will be probabilities, and same things are that. Am I right? Here again, in second question you have to get the probability of each, as the fifth one. You have to also find their means probability related to the x. And same as you know that summation of probability always does be equal to the one. So find the probability related to the all and just sum to that one will be equal to one. Is it okay?
Sir, so we need a characteristic equation to solve for the eigenvalues and eigenspinner of S cap y, but I don't get from where this characteristic matrix, sorry, determinant come.
Okay, you want to know about the origin, that how from where it found, means that
Yes, sir.
matrix is found.
Characteristic determinant
Yeah,
for
yeah, yeah.
calculating eigenvalue.
Okay. So let me see. Uh, you know how to get the eigenvalue from for an eigenvalue equation?
Yes, sir. Just operate the function on the operate the operator on the function, and from that the value that we get along with the function, the value will be eigenvalue.
Yeah, if you know the operator.
Yes, sir.
One way is use matrix to find that one, that particular condition.
Okay.
If you have sorry, if I will be not right, you can say that if you have a particular matrix and you want to get the uh, eigenvalue of that part of that operator, so there's a condition of x minus I lambda is equal to x minus a lambda is equal to 0.
Okay, sir.
Okay, so by that you will be
Yes.
get
Now.
the eigenvalue of that one, and as we get the eigenvalue, so what simplest ratio will be considered the eigenvector. Are you getting what I want to say?
Yes, sir. Yes, sir.
Okay. Okay. Anything else? Hello. Hello. Hello.
Yes,
Uh,
you are audible.
yeah. So say anything if I can help you anyhow.
Yeah, could you tell us, could you just give me a brief idea how to calculate the Coulomb integral?
I think you are going through the equation of the Coulomb. Sorry, you are going through the equation of the Coulomb integral. What is the Coulomb integral? Yes.
How to calculate?
Yeah. Okay.
And it was something like psi 1s 1 over psi 1s 1 1 over r 1 2 psi 1s. 2.
Okay, I have to find to that one. Actually, I don't know also. Okay, yeah, I'll find to that one.
So if you could
Yeah.
you get back to us? Could you get back to me after you have some idea about that?
Yeah, I will try. And I will be told to you.
Oh, thank you.
Okay. Yeah. Sure.
Yeah, any other doubt if you have?
Hello, sir.
Yes, yes.
Sir, could you please explain how to solve the question 9 in the assignment? How do we approach to that question?
Okay. Okay. Let me share initially. Question 9 is. One minute. Wait. So for that, as the in question has given that initially you have to think about the how many eigenstate of SZ are there. So how you can just find that how many of SZ are states are there? Is it related to the possible value of M? For spin 1, you found two possible value, plus of and minus of. Hello.
Yes, sir.
So for spin 1, how many states are possible? Is it 3?
3
Yeah, 3. What are these? -1, 0, and 1.
plus 1. Yes.
Yeah. Later one, can you apply the operator on that? If you apply SZ on that one, particular state, so corresponding eigenvalue you will found. State corresponding to SZ is equal to 1, or sorry, spin related to 1, what we can say. The corresponding value means state के लिए जो eigen value होगी, for SZ के लिए eigen value होगी, that will be 1, -1, and 0. So if you apply SZ on +1 state, so eigen value will be 1. Hello.
Yes, sir.
And on 0 it will be 0, and on -1 will be found the -1. Similarly, on applying the operator +1, raising operator to that one. So if you apply raising operator on plus, then what will be value? Is it 0?
So please repeat again.
State having eigenvalue +1. If you apply raising operator on that, so what will be resultant? Is it 0? At higher value, if you have a system and it has a 3 possible value, +1, 0, and -1. So +1 is a higher value and -1 is a lower value. So if you apply raising operator on a higher value, then what will be resultant? 0.
0.
And if you applying s negative, means you have to apply all this, determine the action of that action you have to determine on each state, and corresponding resultant you found. Means if you apply S plus, means if you apply Sz, so corresponding value will be corresponding to your eigenvalue. Are you getting? How you write the state, particular state, if you know the value of L and M? Hello? Hello?
Yes, sir. You
Yeah.
are audible.
Yeah, thank you. What can we state if you have to write the state corresponding to these three eigenvalue? So how you can write? Okay, so can we write three state corresponding to these 1 plus 1, 1 minus 1, and 1 0? Is it okay?
Yes, sir.
Means 1 corresponding to your spin, corresponding second yoga that will be related to your eigenvalue. So 3 eigenvalue is plus 1 minus 1 0. So you can write 1 plus 1, 1 minus n, and 1 0. Okay. So in matrix form, you can write x. Let's say you have a 3 eigenstate, x plus, x 0, and x minus 1. So for x plus, you can write 1 0 0 column matrix. Hello, are you
Yes,
getting
sir.
my point? Yeah.
Yes, sir.
And
We can write.
for x minus, what you can write? 0 0 minus 1. Okay. Your question may be how one can say that 1 0 0 0 1 0 0 0 minus 1. Is it? What I'm saying
Yes, sir.
that
Yes,
x
sir.
plus
That
b
part also
column.
not clear.
Yeah, that. So you have to apply operator on a particular state. Just apply SZ operator on 1 1. What will be eigenvalue? 1. And if you apply SZ and 1 0, then what will on 0, then what will be value? 0. Just let me write. Uh, 1 minute. Give me 1 minute. Just give me 1 minute. Yeah. So you have a three possible value: 1, 0, and minus 1. Is it okay? Corresponding state will be 1, 1. Second state will be 1, 0. And third one is 1, minus 1. Is it okay?
Yes, sir.
Now just apply SZ on each state. What will be resultant? Just write in a multiple, not necessary to write the h cut and all. So it will be equal to 1. Sz is only spin operator, which is which is the eigenfunction operator. So resultant will be eigenvalue. Yes.
Yes, sir. Yes.
Yeah, good. Sz and 1 0. What will be resultant? 0.
0.
Yeah, good. And Sz on last state. What will be resultant? -1.
-1.
Yeah, good. 1 minute. Just give me 1 minute. So by these value, you can write a matrix of 3 by 3. One, sorry, that will be not here. I'm not using mouse, so there's a problem. Is it okay? Hello? Hello?
Yes, sir. Sir, your screen is not visible.
Oh, sorry. Sorry. It has cut somehow. Sorry, it will be 0. So you can write by this way. Hello? Hello?
Yes, sir.
So this is a way, this is a first try to write the, what we can say, operate matrix related to the SZ. Similarly, you have to apply S plus and S minus on the given state, and later on have to write the matrix. Am I right? Hello?
Yes, sir.
Okay. So anything else?
So if you have any doubt, then you can ask. Otherwise, you can just wrap up the class. Or you can, if you have any doubts regarding the class, you can ask. So we'll tell Professor Rajesh Chakravarti. So we will discuss in the next class also. So if you have no doubt, then we just wrap up the class. So we'll wait for 1 or 2 minutes, then we'll just wrap up the class. If you have any doubt, ask. Otherwise, just close the session. Okay, so I think you have no doubts. So we just wrap up the class and we'll see you in the next class. Okay. Thank you.
Thank you, sir.
Thank you, sir.